All right. So next four methods we are going to talk about. These four functions, they're going to return some value. All right. So unlike these methods which we have discussed just now, so the append, extend, insert, these methods were not returning any value, but they were modifying the list there itself. All right. In all the modifications were done in the original list. So no new list is created here. But if we talk about these methods, which are named as pop, index, count, copy. So these methods, they're going to return some value. This is the additional thing about these methods. That is why they are separated from the existing list. Now let's say one by one we are going to discuss these methods. First is pop. I think you are aware of what pop function does, pop method does. We have used this pop in stack, last in first out. When we want to just take out the last element of the stack, okay, then we can simply make use of pop function. All right, the same functionality is given in list as well. Let's take one example where we have a list of items, list of objects where multiple objects are given. All right, now I can say I want to pop out the element from the list. So since these methods will return some value, this will return by default. If you are not providing any value in the argument, it will give you the last value as the output. So it will return what? 10. Okay, or you can say -1. It's the same. So by default, -1 is the index which is given. I can pop out any value. Let's say I want to just delete that particular value and retrieve it also. So deleting will just delete the value, and this, if you pop out a particular value, it will just take out that particular, delete it, and it will give you the output as well. This is the difference. If you see it, it is what? It is deleting the value. There were two twos, and you are deleting this, you are popping out the second value 0, 1, 2. So the second index value which is present in the second index is getting deleted, and you are getting the value as well. This value is getting popped out as well. All right. So this is the benefit of using this pop function over here. In general, you can implement a stack using list in Python with the use of append and pop function. All right. For example, if you want to, how your stack works in a LIFO method, last in first out. So if you want to add a particular object in this stack, then you can simply use append function. If you want to append 11, that item will be added at the end of the list, and nothing will be returned because append function does not return anything, and it will happen in place. Okay, so the existing list will be modified. If you check, so this is what push operation in the list. So you are implementing the stack using list with the help of append and pop function. Sorry. Now I want to pop out the element. So by default, I want the stack operation, the last value should be popped out. So if you print this, you'll get what? 11 is the answer. The last value which was added was popped out. So in this way, you can make use of these append and pop functions, and pop is one of the methods which is returning your value also, right? Now next we have is index. As the name suggests, index means finding out a particular object. Okay, at a particular, what is the index of this object? This is the meaning of index function. For example, you have a list. This is the list. I want to know what is the index of object 2. So this object you have to give, and you are looking for the index in this particular list. So it will return you a value. Again, this function returns the value, and what value it is returning? It is returning you the index. So it is saying at index 1, the value 2 is present. Always it is going to give you the first occurrence. All right. If you want to delete a value, it will delete the first occurrence. If you want to, whatever you are doing, so it is always the first occurrence, first occurrence of a value which is going to be modified. So again, if I am looking for the index, it will give you the index of only the first object, even if we have the duplicate objects present in this list. And there is another syntax also. If you look at the list, the index method, it is taking two more arguments, start and stop. Okay, it returns first index of value. Okay, first means in case of duplicate values. Now it is saying two more arguments you can pass. So I can pass two more arguments. That is, if I want to look for this object at the end of the list, suppose the list is huge, and I just want to check whether a particular element object exists at the end side of the list. So I can say, let's say I want to look at index number from 5 to 10. In these index values, I would like to look for this object 2. And if it is there, it will say 2 is in the list, otherwise it will say 2 is not in the list. So you can see from index 5 to 10, 0, 1, 2, 3, 4, 5. From this index to the end of the list, you are saying search for 2. So obviously it is not present. Instead, if I say look for the value of 2 in the index 0 to 4, so it will say 2 is not in the list. 0 to 4 index. Just a second. First, we'll have to print what L is representing here. This is your L, and now I want to check L dot index. Find the index of 2 in. Okay, so it is present. So the index of this 2 exists in which location? In the first location. This is the index it is given you. So in this way, you can make use of this index function. Next we have is count and copy. Count, as the name suggests, it will give you the count of a particular number. Suppose this is your original list. I want to count how many times, how many duplicate objects are existing here. Okay, what is the count of a particular object? So if I say L dot count, let me know how many integer, this 5 objects, integer, which is a number 5, exist. So it will say 1 because the existence of 5 occurs at this place just once. So if I say 2, it will give you 2. So how many counts are there? 2 counts are there. So you need to remember these names of the functions. These are the predefined support provided for you in Python in the form of functions. And if I say copy, it will give you a shallow copy of this function. If I say make a copy of this L. This L itself is a list we have already created. I want to make a copy of this list, and this copy will be returned by Z. And I want to print both the lists. See, a new copy of a existing list is created. If you want to check whether the elements are equal or not, both the lists are equal or not, then you can check L double equals to Z, and you can check if L is Z. The answer is true and false. What is the meaning? The meaning is both the elements of list L and Z are equal. That is fine. If you are comparing the elements are equal. But if you are using the is operator, it means they are not referring to the same memory location. If you talk about L and Z, they are obviously they have the same order of elements. They are the same. They have same content. But if you talk about the memory location, they are two different objects in memory. That is why L is Z is giving you false as the answer, right? If you want to cross check it once more, then you can see, just modify the value of Z, modify the index of 1, 2, let's say RAM, and then you check the values of L and Z. See, the modification only took place in the list L. It didn't take place in Z. Why? Because these two are separate lists in memory. So in this way, you can perform the operations. All right. Next we have is list comprehension. Again, it's a very, very powerful function. Powerful, you can say, a technique which you can use to make your code more concise and in readable form. I'll take one example to make you understand this particular topic. So let's take one example where you have to, let's say, you have a list of numbers 1, 2, 3, 4, 5. Right? Now the question is, you have to find the square of every number, and you need to store those numbers. The square of every number should be stored in a new list, and you need to print the list. So what you have to do? This is your question. You have to find the square of every single number, and you have to store it in a new list. So what you have to do, if you use a normal for loop, you write for I in L. You take every number, find the square, okay, and then you have to add the square in a list. So you have to create a new list, the empty list. That list you can create. There are two ways. You can use list directly here, or you can simply write this operator. Okay. So this time let's use this one. This list. Simply you can call the constructor over here. And I've written square, I square I have found out. So that means 1 square. So 1 square has to be appended in the new list. So can I write append this I square in the new list? So in this way, when the first time loop is executing, what is the value of I? I is 1. So 1 into 1 is getting appended in the new list. Similarly, when the second time the loop is executing, the 2 into 2 is appending in the new list. Similarly, 3, 4, and 5. If we take the answer, we can look for the new list. So it is giving you the square of every single number. So a new list is created and you have used append function. Alright, so this is a very simple case. What if you have to do the same thing using only one statement? Can I achieve something like that? It's very, very simple. You can write, you just look at the syntax very carefully. Alright, so what the syntax is, it is saying use square bracket. I'm using the right hand side syntax. Use the square bracket. Inside square bracket, I'm writing expression. What is the expression here? The multiplication of two numbers. So I can write expression here, I into I. Then I'm writing for. Then I'm writing what is the condition? I in L. What is this L? This is a collection. Okay, any iterable item. So for I in N, I square. That's it. Closed. And if you simply print the value, okay, and just comment it out, the entire thing you need to comment out and see the difference. The same output you're getting. And just by writing one single statement, you don't have to write anything else. So this is this is a very powerful tool they have provided you in the form of list comprehension. Syntax is little bit awkward at the beginning, but once you are used to it, it will be very, very handy for you. All right. So if you see the syntax carefully, this is your for loop in general, whatever you write, okay, that the for loop you have written over here. And then whatever the expression is, whatever you're finding the square, you find the cube, you're finding the square root, whatever you're finding it out, you need to just write it before this for loop as a part of expression and enclose everything in the square bracket. Why they have enclosed everything in the square bracket? Because finally we are appending everything in a new list. So you don't have to declare a new list and then you have to append it manually. Okay, like explicitly by writing two statements. You can simply use this square bracket that is a list itself and everything is present inside the list and a new list was already created. I can write new list is equals to this and I can print this new list the same. So this is a very handy feature. One more modification to this list comprehension is there that I'll show you is the filtering out of data. Now let's say I am asking you to provide the square of numbers, square of only odd numbers. So there are numbers, let's say there are more numbers 6, 7, 8. Now when you find the squares, it is giving you the square of all the numbers. Now I want to filter out this data and I want to find the square of only odd numbers, that is 1, 3, 5, and 7. So that filtering out operation you have to write in the if condition. Okay, so apart from these statements, you have to just additionally write the filtering operation, that is if condition. So if you want to modify this, you have to simply write the same thing. You can copy and paste over here because you are ultimately finding the square of a number but finding the square of what? Only odd number. So if a number is not divisible by 2, then you can say this is the condition, this is the filtering out operation, only odd numbers were given, and from the odd numbers you will have to find the squares. And if you print the value, then you can see the output. Only the odd squares it is giving you. Isn't this simple? It looks quite complex, but it's very, very easy. Once you understand the syntax, and it's very easy to just write it down in a single statement. Now, what if you have to write, just comment it out, and what if you have to use for loop for the same functionality? What do you have to do? After writing the for loop, you have to use if condition, I mod 2 is not equals to 0, then you need to append this thing in a list, and then you print it out. You're doing, but how many statements will you write? 1, 2, 3, 4, and finally printing it out. So let's say 4 statements you have to write. But in this case, only one statement you had to write. So just go through it again. if you didn't understand it. But make sure you make a habit of using it, then it will be very easy. But it is not a compulsion that you have to use it. If you do not understand it or if you find it complex, you can just make it simple and you can simply use these for loops and if condition as per as per your requirement. All right. So this was regarding this comprehension, and the topics are covered from my side, and that's it. Thank you.